Yes guys, I did it! Welcome back to the off-grid garage here in not so sunny Australia. Look at all these clouds. It is insane. I finally had some time to paint the battery room from the outside. And I've chosen this amazing blue color with a little bit of orange. Yeah, and basically that's how the battery and system room looks like from the outside. I haven't done the door yet. And I think it looks freaking amazing. Yeah, especially when you have the light reflecting on the wall. You've got this darker blue up here, a lighter blue down here, and another darker blue down here again. And then this crispy orange stripe. Looks familiar? I really couldn't help myself. I wanted to give this one a try and see how it looks like. Anyway, we are not here to talk about painting or how good or bad my taste is. We are here to talk about the battery shelf. Guys, we have to do it. We have to start with this huge project. I'm pushing this. I try to delay it as much as possible because it will be so much work. I've done it once and now we have to do it again. Hopefully with a better result. But we will see this in a year, 2 years, maybe. It's a bit of a long-term project and test. All right, yeah, we are talking about the middle shelf battery here. Because this bank was disconnecting for the last 2 or 3 weeks with a cell under voltage protection every single morning. And because these are EVE LF280 cells, not the K variant, the 280, I always had problems with these cells from the beginning. And it is not so much the cell chemistry or how much capacity they have or whatever. It is more about the terminals. The terminals are terrible. This was one of the last delivery of cells which had the set screws. So it's a threaded terminal where you have to put a set screw in and then your bus bar and secure this all with a nut. And they must have used some terrible aluminium for that, because I'm always having issues with oxidation between the battery terminal and the bus bar. And then you're ending up at some stage like having crazy 250, 300, 400 millivolt deviation across all your 16 cells. And the poor balancer in this BMS here was trying to balance this battery, but obviously was unable to. This battery never got fully balanced for quite a while. Yeah, at the same time, I want to replace this BMS here with another B-series JK Inverter BMS. You probably can see this down here already. This is a newer one. And I also have the P-link communication board already mounted on the back of the battery shelf. And I want to do exactly the same in this shelf here. Yeah, and then we can connect all 3 batteries with the communication boards together and have them communicating to Victron. And we will get all the information into Victron down to the cell level. And that is very important to monitor these batteries here, because I think I have to maintain or redo the bus bars every 2 or 3 years. But this time I got myself the MG Chemical 847 carbon conductive assembly paste. So this was one of the recommendations, of the many recommendations you left under my videos to use for aluminium bus bars and terminals. So we give this one a try. I've never used it, I think. Oh yeah, I did. Yeah, it's already open, yeah. But I'm not 100% sure if I should reuse the aluminium bus bars, Paul's aluminium bus bars again, or if I should stick with the copper bus bars. As you can see, these were the old ones we had installed on this battery, and they all have the M3 thread in here for the balance cables. Because then you have aluminium on aluminium and have this paste, this cream in between here, and this hopefully prevents the aluminium contacts from oxidation. Or should I stick with the tinned copper bus bars, which I have installed right now? Yeah, when I removed the aluminium bus bars probably 1.5 years ago or something and put the copper bus bars on top of the battery, everything went smoothly and fine and the battery was performing just like on the first day. But then over time this problem came back and I think the oxidation started in again. I think it is just these bad aluminium terminals of these cells. This was just before we got all the cells with welded studs. And I've got another battery here. This is the first one, yeah, which was sitting in the plastic tub. You remember battery 1.0 with the world famous cells 6, 7 and 8, which were always low in this battery. Yeah, that was the time back then when I polished the terminals. Yeah, I tried to get them as smooth as possible, but it didn't help with the oxidation, and after a while the problem came back. So this is this battery with the set screws and the threaded terminals, and battery bank number 2. Probably at some stage I'll take out all these cells here and replace them with new ones. And I put these ones in a do-it-yourself box. Then I can have the do-it-yourself box sitting on top of a stack of other batteries, and it's easier to maintain because you have to take off all the bus bars, clean all the contacts, and put the paste back on, bus bars back on. It's just insane, and it is really a pain in the ass to do this here in the battery shelf because the space is not very much. We start with the second and maybe easier task to replace the BMS. It might be the last time I'm looking into this BMS for a long time. Yeah, look at the top here. The time, 4 years, 112 days, 15 hours, 12 minutes and 5 seconds. That's how long this BMS is running here in the battery shelf. The first JK BMS we ever had here in the off-grid garage, we ever tested. And it says, to start the BMS, apply 5 volts, positive to B negative, and negative to P negative. Because this one doesn't have a power button. It doesn't have a display. No way to start up this BMS, and the only way to do it was to applying 5 volts between this point, and then it was starting up. I mean, let's have a look what this is. Look at this serial number, how low it is. It's a B2A24S20P. So 2 amp active balancer, 24S and 200 amp altogether. Hardware version 7, software version 701. It has been powered on 69 times only in over 4 years. It was just running here, manufacturing date 2021. I think when we take this one out here, we should put it in like a little frame or something and have it somewhere here in the battery room and have a sign across it saying, "The Legend." Yeah, this was the very first JK BMS we've ever tested here. Discovered the active balancer. It was a breakthrough back then because no other BMS out there had such a strong balance capability. And I did a lot of videos about this BMS here, and then people started buying it. Yeah, and it created this worldwide tsunami. Yeah, everyone used the JK BMS from there on because the balancing function was so superb, so much more advanced than in any other BMS, JBD, Dali, Seplos, you name it. This one ate them all for breakfast. Yeah, but now it is unfortunately time to say goodbye. All right, let's isolate the battery and take this one out. And I am going to replace this BMS with this BMS. Yes, that is another B-series JK-BMS. I think it is almost identical. B2A24S200P, exactly. Except this one has also H, C, R and Y, which is something like the heating port, CAN and RS485 communication. And this is pretty much the only reason I'm replacing this BMS with this one, because of the communication possibilities. Yeah, even the old one says we've got CAN and GPS RS485. The connectors are a bit different, and even if they would fit, this one hasn't got the right firmware to communicate. So unfortunately, bye-bye JK-BMS, welcome JK-BMS. Yeah, unfortunately the new JK-BMS has a bit of shorter cables than the old one. But this is probably 10 mil here and another 10 mil on the other side, which will make it almost impossible to connect. See how much space there is between the end of the cable and the terminal? And I don't want to have the BMS like this, so the cables actually fit. So I thought, no problem, Andy, just get some longer ring lugs. And these can then extend your cables, and you've got no trouble to connect this BMS back in the same position as the old one was. So I got the ring lugs. So I must have had a bit of a knot in my mind when I ordered them. But if you put your cable in, it doesn't actually give you any extension at all, because the cable still ends where the barrel ends. So the whole thing isn't actually longer than the old ones. Unless I don't push them all the way in, but only until here. Then again, exactly the 10 millimeters I need per side to make this work. And this still gives me enough space to crimp it twice to have a really good connection. Yeah, alternatively, I bought some 7 gauge wire as well, silicon wire, to replace all these wires here in the BMS. But this is a bit messy because they are soldered inside the BMS. And I would need to get my 150 watt soldering iron out and get rid of these cables, put the longer ones in. So I've tested my whole theory down here already with this one with the longer ring lugs, and it works perfectly. Yeah, it gives me enough space on the left and right. Okay, let's get this done and see how it works. I've used the 10 millimeter dies for this crimp because the ring lugs are a bit large for this 7 gauge wire. It is 7 gauge wire, it's not 6 and not 8, it's 7. So it doesn't really fit the 16 millimeter, but 10 millimeter ring lugs are too small and 16 is a bit too wide, see? So we have to file this excess material off here to make them round again. But this is what we always did with these connections. But I think apart from that, it gives us the 10 millimeter extension we need. So before I crimp the next one, I need to ensure this one is actually upside down. It looks like this because the ring lugs will be sitting on top of each other like this. Because if they are facing the same way, they go a bit in an angle, yeah? They cannot sit on top of each other. So I've just filed this excess material away, make this shape a bit round again, ensure there's no sharp corners anywhere. And now it's time for a bit of heat shrink. And unfortunately, I have only black and red heat shrink. No blue one in stock at the moment, but at the end it is the negative path of the battery, so black is fine, kind of. And we also put a bit of yellow heat shrink at the end of the heating wire. Yeah, nah, look at this shit. Nah. That needs to come off again. Terrible. That is terrible stuff. There it says 13 millimeter 2:1. Shit. Alright, let me have a look in stock what I have. Alright. So let's see how it fits. So one goes down, one goes up, and the same over here, or other way around. This one first, this one on top. And it sits perfectly straight. Look at this shit. I like it. That is very good for my OCD. And the best part is, the balance cables will fit the new BMS. So I don't need to do anything with these ones. They just stay there and fit in the new one. So, alright, in the next step we want to mount the communication board in the back of the battery shelf. So similar to what I've done here. And for the communication board, I found this 3D printed case online. And the board just goes in. Yeah, it sits behind this panel. Yeah, really good, but it is too large. For such a small PCB, this design is far too large. So I made my own smaller version of that, and I made this box only a bit larger than the actual PCB is. And then we've got a snap-on front panel. There you go. Hole in the back for the cable, but we need to drill another one because the cables are coming this way. JK-BMS P-link RS485 parallel and CAN and RS485 external LED. It's a bit smaller than this one, right? I'll link both variants down under the video. But of course I faced another problem. Too short. Much better. The challenge with these brass inserts into the 3D printed plastic is to not make the soldering iron too hot. So I found out 200 degrees is actually pretty good, and it sinks smoothly and slowly into the plastic. So with the drilling inside the battery stuff, we have to be a bit careful. Don't want to have any metal debris inside the box. So what I'm using is a bit of tape, and I'm making this small pocket like this. And when I drill, everything falls into the pocket and sticks to the tape. Then I'll take my pocket, and there's all the rubbish. So we now just need to connect the extension cables. We run them through the hole. Then I found a bit of split loom, because in the bottom shelf I used Velcro, but this split loom may be the better solution. It looks probably a bit cleaner. Pain in the ass to get this in, especially when it's in the shelf. Okay, we have to undo this again. It's just the order wrong. I need to get the cable first into the split loom, but not inside the battery shelf. All right, and the other two go to the BMS. One is the CAN RS485 connector, and the other one is the GPS port. We pop on the lid. We could use these sticky mounting points here on the cable tie to secure this a bit, but I'll leave it as it is for a moment and see how I feel about it. Yeah, definitely a better solution than just having the cables with some Velcro. This is a bit messy down there. Alright, so and in the final step we plug in the BMS. This big connector first. This one. Alright, what I haven't plugged in yet is a switch to turn it on. And we also have 4 temperature sensors, which go just here in the corner. Over there. All right, everything is plugged in. All right, here's the big moment. Beeps and turns on. Oh, nice. Okay, so that must be the one with a long number, because it hasn't got a name yet. 1, 2, 3, 4. That's a version 19A. And it runs software version 1900. Oh, that's not good. I think the other one in the bottom runs 1904, but there's also a newer one available already, which fixes a couple of problems. So I probably put the new one on straight away. And yeah, all the cells are here. Perfect. And we have LFP, yes, 16 cells, capacity 280. I think everything is pretty much set up as per my defaults, except the balanced start voltage is too low with 3 volts only. 3.65, RCV 3.45, reset at 3.445, recovery, yeah, could be a bit higher. Undervoltage protection 2.5, 2.7, it shows 0, and power off at 2.49. Charge current 100 amps. Okay, we set this one maybe to 60 amps only. And this one here to 60 amps as well. Because I've got so many batteries in parallel, we don't need to have 100 amps per BMS or per battery. And I think everything else is fine. So just ensuring the UART2 protocol sits on JK-BMS. Modbus version 1. And that's pretty much it. That concludes the upgrade of the JK B-series BMS to a JK B-series BMS. Alright, I've got the communication there in the RS485 parallel port, which goes to up here, and then the other one, the other RS485, goes all the way up here to the master BMS, which is a JK Inverter BMS B-series with a P-link. So these 3 BMSs should communicate if we set the address right. Okay, let's have a quick look what's going on here in the off-grid garage. And we should see the JK-BMS somewhere connected via CAN. Ah, yep, there it is. And this should be only a single one. Go to details. Yep, that is the only one. That's the master, so to speak, but it's not the master. It's actually sitting on ID 5 because it was connected to the other 4 Google Power batteries on the other side. Let's go into the app. #1, there it is. No, yes, it is #1. Settings, password, all the way down to, there it is, device address 5. Now this should be device address 0. Bam. Yeah, and changes immediately. 3 online. What? 4 online. 6. What's going on here? Now it comes down again. It was a bit confused. So this is address 0. This is our master. That's the top shelf battery. Then we go into the, here, battery 2. This is the one we just installed. Settings, password, different password. 1, 2, 3, 4, 5, 6. Verify. Device address 1. That is correct. First slave. And battery number 3. There it is. That's the bottom shelf battery. Password. 1, 2, 3, 4, 5, 6. Address number 6. Shouldn't make a difference. Yeah, we can see it already here. Highest cell voltage is in battery number 6, yeah, which is our bottom shelf battery. But for the sake of keeping right in order, let's do this one, device address number 2, yeah. We've got 0, master, top shelf, slave, middle shelf, slave 2, bottom shelf. Yeah, exactly. So number 2, this should change in here to highest cell voltage in battery number 2. It's getting a bit confused now. Yep, here it comes down again. All right. And we should see 864 ampere hours, if I'm not mistaken. 280 plus 280 plus 304 at the top shelf. 86, yep, there it is, 864. And we have available 275 at the moment. So perfect. Communication works between the JK Inverter BMS in the top and the slave batteries BMSs, which are JK B-series BMS with a P-link communication board. And they communicate with RS485, but the master at the top is connected via CAN. It's a cannable adapter, I linked this down below, plugged into the Raspberry Pi running in Venus OS, and it shows all the information online. You don't need to do anything, it just works. It's just a plug and play shit and everything works. Yeah, battery 0, battery 1, battery 2, highest, lowest cell voltage, temperature, everything is here. And it also combines the alarm, so if any of the BMS has an alarm, it will show here as well. History may not be correct now because, yeah, these are all 3 new BMSs now. And we also have the parameters, which sits on 55.2 volts. This is coming from the master BMS only. And these 136 amps charge and 187 amps discharge current is an aggregated data value from all 3 BMSs, which the master does and reports this to the Victron system here. So at the moment, all 3 BMSs would take 136 amps maximum, and then Venus OS would throttle down your inverter or your MPPTs. So we would not exceed 136 ampere hours at the moment, so which is good. All right, let's test this out. Go into details again. And we can see down here, numbers of modules blocking charge and discharge is 0. We are in battery number 3 at the moment. We go all the way up and we just click on discharge. Yeah, we disable discharge. And we can see immediately 3 BMSs are online, so communication works. But one of them is actually blocking discharge. And we should also see this reflecting in the parameters requesting from your inverter. Yeah, see the discharge has come down from, I'll turn it back on, takes a moment. Yeah, 187 amps. And when I disable discharge in one of the BMS, it also allows a lower discharge current for all your battery banks in common then. 136, perfect. And if I disable charge here at the same time, we should see the charge current limit going down from 136 to under 100 something, I don't know. There goes 88 amps. That's the maximum with 2 BMS remaining. So everything works perfectly. Okay, turn this all back on. So as you can see, with the communication established to the inverter now, the inverter knows exactly what's going on in all connected batteries now, yeah? It knows which bank has the highest, which bank has the lowest voltage, and the same for the temperature. If any of the batteries has an alarm, the inverter knows about it. If one of your BMSs gets too hot and turns off charging, the BMS will know about it and reduce the charging current. And this was certainly something we didn't have before with the older style B-series JK-BMS, because they didn't have the communication. But this is now the native communication setup between the JK B-series BMS, the JK Inverter BMS. No additional hardware, no additional software, just plug and play. Works with almost all inverters out there. And this communication now gives you the additional safety layer, because your charger will react to whatever the BMS report. Yeah, I also found a bit of split loom for the top shelf battery here. This wasn't quite nice. Need to clean up these cables there, and I'm still waiting for the longer ribbon cable. This is only a 500 mil. I ordered a 700 mil now, and then it should fold nicely. Alright, that's a very good progress. Upgraded all 3 BMSs now in the battery shelf. As I said, we kept the original design and purpose of the battery shelf, but now we've got reliable communication established between all these 3 BMSs. And I can plug in all the other BMS which are connected at the moment as well, and the master would report all the data combined to the Venus system, to your inverter. Keeps it all safe, right? If one of the BMS drops out, the inverter reduces the power. Alright my friends, I think so far this video for today, upgrading the middle shelf battery, which was the last one to do. Yeah, I did this one earlier here and it was a bit pain in the ass because it is very hard to reach. You have to lie on the ground basically and then work inside there. But now it is all done, it is all cabled, all working, communication established. Alright, and then looking further in the future, the cable has arrived here. This is 95mm cable, and we have to install this one between the battery shelf and the new power wall on the other side of the room. Yeah, basically here from the main busbar system, running in the duct across the cable tray to the other side, coming down here and connecting to the main circuit breaker for all these batteries connected in the future. So this is something we have to do very, very quickly in the next week, I think, because I've got some very exciting news to share. In 1.5 weeks time, the electrician comes back and takes our house off grid. Yeah, we will be connecting the house to the battery shelf, to all the other batteries, to the inverters, and it will be completely off-grid, standalone, not connected to the grid anymore. 1.5 weeks only. As excited I am, I'm also a bit scared about this step because it comes a lot earlier than expected. And I know we will struggle a bit in winter time because we haven't got enough solar, because the grid connected solar is still connected to the grid, obviously, and it's pumping energy in until the feed-in contract ends in 2028. So that's another 2 years. But we are in the middle of winter now, so we've got the winter solstice. The days are getting longer then, so we're going into spring slowly, very slowly, of course, only. And solar production will increase again. So it is only one winter where we are struggling, which is winter 2027 down here for a couple of months, but hopefully we can connect as many batteries as possible during summer and recharge them, and this energy will last us through winter, because I only need a few kilowatt hours here and there per day in winter time to make it through winter. But we will see all this once we get there. First big task is to put these cables in. This will be a major task to run these 4 95mm cables from here all the way across to the other side. Yeah, we have to disconnect all these batteries here and move them away, because the electrician needs to get access to the inverters and the distribution panels over there in the corner, and the meter box is just on the other side where the house is actually connected to, and this all needs to feed in back to the inverter. He will cable all this stuff then, so we don't have these additional batteries anymore, and I'm solely reliant on these 3 batteries, like in the good old days basically. And because we have to power down the DC bus in order to connect these big cables here, I don't want to do this once the house is connected, because then, well, we don't have power in the house, right? So we need to connect these cables before the electrician comes in and does the changeover. And then the cables will basically end over there, and I can disconnect them with the main breaker and can safely work on the other part. Yeah, and I also got myself a battery-operated hydraulic crimper, because I have to do quite a lot of crimping here. And I didn't want to use the leaking hand manual hydraulic crimper for that. But more about this all in future videos. Alright my friends, as always, thank you so much for watching. Thanks for all your amazing support. For all these wonderful and beautiful people who are donating to the channel here, buying me a spat. Thank you very, very much. Becoming a channel member, thank you. And welcome to all the new subscribers here. I haven't looked for a while. We are over 123,000 or something. Quite amazing. Thank you very much. More videos are on the way, guys. If you like this sort of stuff here, subscribe to the channel. It is free. Leave a nice comment under the video. Hit the like button. And until the next video, guys, you stay charged, stay safe, and thanks again for watching. See you then. Bye-bye.